Guys, I'm so sorry. I pressed the wrong button. Go tell all your friends. Go tell everyone to come to this one. I'm so sorry. I pressed the wrong button. I'm so sorry. Come back. I'm so sorry. Come back. Oh, you guys, why does technology hate me? Oh, I swear I'm cursed. Like, I swear to you, I am cursed by, like, Alexander Graham Bell. Like, this man hates me. Oh, I'm so sorry, you guys. Oh, come back. I'm so sorry. I posted on Edmodo. Text your friends. I'm so sorry. Yes, the telephone guy, Lana. Can we do tables with missing numbers? Yes. We will do it all. I promise, Rohit. That's the second time you've asked. I swear it's coming, bud. I want to, like, get you guys to understand the flow. Because if you understand, like, one step, it's way easier to do the other seven. Do we know the definition of a relation? It's any set of ordered pairs. Okay. It's up again. Thanks, Chandana. Okay. Can we get Squidward in here? No. This is a school appropriate chat. Okay. Never mind. All right, Ayush figured it out, guys. Natalie, is that Bob Tomato? Did you change your name back? All right. We're at 19. Okay, we're at 19. We had 20 before. I'm going to start. Okay. So, the first concept that we learned is a relation, and that is any set of ordered pairs. Okay? Any set of ordered pairs. A subsection of relations is a function. And a function is a type of relation in which there is one, there is one output for every input. Or, saying the exact same thing, just in a different way, every input has exactly one output. Yeah, okay, Ava, leave me alone, all right? No, a relation is any set of ordered pairs, no matter what it is. The exactly one output is a function, which is a subset of a relation. Hey, Suda, stop. Okay, so would... Natalie, you can't just leave it with an ellipses. Would what? Okay, function has two subsections. Linear, and nonlinear. Okay? Those are words. Linear and nonlinear. Now, yes, Natalie, that is a function. Okay. So, linear, nonlinear. The different ways we represent linear and nonlinear are tables, tables, graphs, and equations. Okay, so let's start with tables. Bottom left said linear, Casey. Okay. We're going to start with tables. Hold on, I have too many papers. There's so many examples, you guys. Okay. So, if we're given a set of data, let's say we have -2, 5, -1, 4, 0, 3, 1, 2, and 2, 1. Okay, so these are our values to start with. The first thing we're going to do is list our domain and range. So we have domain, remember the squiggle, remember the squiggle. Okay, our lowest value is -2, our next value is -1, 0, 1, and 2. This was an easy one because they were in numerical order. Remember to finish the squiggle on the other side. Allie, what are you confused about? Range is your y values. So we're going to go in order. So notice the lowest value is 1. So we're going to go 1, 2, 3, 4, 5. Okay? That crosses off our y values. So that's our domain and range. Correct, Allie. So basically we have to have them in order, right? Yes, correct, without them repeating correct. Put both x and y in order, correct. When you're listing domain and range, put both x and y in order. So the easiest way is to just go from a table, because first we have to label x and y. Remember to label x and y. That's going to lose you points, I promise you that. Yes, you will lose points for squiggly lines, and you will lose points for not labeling x and y. Natalie, the y can repeat in the range and it still be a function. The x can't repeat, which is the domain. It would not be a function. So we're going to take our domain, which is a synonym for x. X is not a synonym for itself, ladies and gentlemen. Domain is a synonym for x. So we're just going to drop these down in order because they go in order. So we're going to go 0, 1, 2. Okay, notice how I just took those from there and put them there. I'm going to do the exact same thing in range. I'm going to put 1, 2, 3, 4, and 5. And I'm now going to match them up to what the coordinates originally were. So it's -2 over here. Well, that was at 5, so I'm going to draw a line. Connecting them, I know that's good. -1 to 4, I'm going to take this and I'm going to draw that line right there. 0 to 3, I'm going to take the 0 and connect it to a 3. 1 to 2, I'm going to take the 1, connect it to a 2. And 2, 1, I'm going to take this and connect it here. Now immediately, not only did I notice it's a function because there wasn't a repeated domain, there wasn't 2 x's, but I also notice here there's no peace sign this way. There is no x value that goes to 2 y values. There is no input that has multiple outputs. So y, yes, Natalie, y's should be in order when mapping. Now, here's where we get a little twisted just because mathematicians are evil. You're going to take a table and only the x's need to be in order. We will get it wrong if we don't put arrows. Yes, why? How would we know what you're talking about if you don't put arrows, Daniel? You have to put arrows. Yes, please make your markers neat. Like, this isn't like where you say true, false, and like it looks like you're trying to make it look like both. No, that's not this game. We're not playing that. Okay. Natalie, what are you confused about? Okay, we're going to move on. Okay, so now, because mathematicians are evil, we're going to only have to put the x's in order. So we already have our x's in order up here, so we're going to put the x's in order. So we're going to put -2, excuse me, oh, wrong side of the marker. -2, -1, 0, 1, and 2. And now, instead of putting the y's in order like we did on the circle things called maps, we're going to put them with what the original value is with. So it's going to be -2, 5, -1, 4, 0, 3, 1, 2, and 2, 1. So that's how we get, if we're given a set of coordinates or set of data, that's how we create a domain, a range, a map, and a table. Now, what's likely, hint, hint, nudge, nudge, going to happen is that you're going to be given a map and you have to create a table from it. So if you're given a map and it asks you if it's linear or not. Okay, sorry, y'all's comment distracted me. So if you're given a map and it asks you if it's linear or not, the easiest way to do this, and y'all are gifted, so I understand you're like immediately going to try and see a pattern and shortcut this, but please don't, because I promise it's going to trip you up. So make a table out of this map. So when you're given this image, go ahead and make a table and say X, Y. Well, you're already benefited because the X's are already in order. So literally just copy this section to here. So we're going to write -2, -1, 0, 1, 2. All right, check. Now, since my Y's are what go with it, I'm going to look at the arrow. My -2, and this is why you need to write neatly. -2 points to 5, so my coordinate is -2, 5. My -1 is pointing to 4, so my y coordinate is 4. My 0 is pointing to 3, so my 0 y coordinate is 3. My 1 is neatly pointing to my 2, so 2 is going to go here, and 2 is neatly pointing to 1, so that's going to go here. So now I've created a table from my map. Now I can determine if it's linear or not. And when determining if a function is linear or not, when given its table, the first step is to create a constant, or the first step, pardon me, is to look for a constant rate of change. Real quick, check in because no one's commented in 2 minutes and it's freaking me out. We all still here? Gia Crocs. Constant rate of change, hashtag Crocs. Okay, that's great. All right, so let's talk. Awesome. Okay, great, guys. Okay, so let's talk about how we check if it's a linear function. So -2 to -1 is a positive 1. -1 to 0 is a positive 1. 0 to 1 is a positive 1, and 1 to 2 is a positive 1. So we're good on this side. So when we're looking at a rate of change, our x is our numerator. So this is going to be equals 1. Okay, all of these are 1. So that means if this is over 1, all of these should be the same too. So 5 to 4 is down 1, 4 to 3 is down 1, 3 to 2 is down 1, and 2 to 1 is down 1. So my numerator is -1. That's my y value. It's -1. So -1 divided by 1, well, negative divided by positive is negative, and 1 divided by 1 is 1. So my constant rate of change, or Crocs, is going to be -1, which means every time I go over here 1, I go down 1 here. So that's how I know it's linear, because there is a constant rate of change. So when I was given a map, I created a table, I looked for a constant rate of change, and I found that. This is the amount of work we expect to see when given this problem. Understand? Okay, Casey, chill out with the y equals mx plus b, m slope b, stop. Because that's the next unit, and we're not going to try and teach that over YouTube Live right now. So Casey, don't drop that info yet. I really appreciate that you know that, and that's awesome. And we're definitely, absolutely going to find equations from tables and maps. But that's next unit, and I don't want to confuse that concept when we're less than like 18 hours away from a test. Okay, bud? Thanks. The Crocs don't have to be the same side in each order. They have to be a proportional relationship. So like if this was a 1 to 1, this would need to be a 2 to 2. Like if this went up 2, this would have to go up 2. They have to be linear. It has to be a constant proportional relation. No, I assure. What? Why is Mr. Veter on here? Who's Fred Veter? Is Mr. Veter on here? What's up, bud? Stop, he is. Hey, Mr. Veter. Oh, this is so cool. Okay, awesome. Oh, I'm so excited, guys. This is so awesome. Okay, so we've gone from a map to a table, and we've determined if it's linear by using proportional relationships, okay? All right. So let's move on to what happens when we're given a table and we need to find a value. How about that? All right, give me a second to write the value. Y'all talk amongst yourselves. Hey, Shadow. What's up, Shadow? Okay. So we just found out from a map to a table constant rate of change. So what we do when we're missing values in a table is we try and find the constant rate of change. So what we're going to do here is look for our rate of change on our x and then see if it's proportional to our values on our y. So if we go from negative to -5, well, that's up 5. Don't get tricked up by negatives. -5 to 0 is up 5. 0 to 5 is up 5. Now, don't be tempted to just like follow the pattern and be like, okay, well, up 5, that's 10. You have to see what the relationship on the other side is. Don't shortcut this. And I feel like some of you are going to, but don't be tempted, okay? Don't shortcut that. So 5 to 4 is -1. 4 to we don't know is I don't know. I don't know to 2 is I don't know. And 2 to 0 is -2. Well, we already see some similarities. We already see that there's negatives on both sides. So let's go ahead and create. Why do we have to do negatives though? Because you're going to see positive and negative slopes. Because you're going to see that it's a negative value. You're going down for every time that goes up, and a negative divided by a positive is a negative. Okay. So, are we still on the definition of functions, guys? Whew. I don't know if he's still here. So, I think he's just watching. So we're going to take this one to go to this one. So we're going to have -1 over 5. That's our baseline. That's our constant rate of change. So I like to cross that off because that means I've dealt with it. I've moved on. Well, this went up 5. So what does my constant rate of change say that has to do? Well, that has to go, oh, pardon me, I lost the negative. That has to go down 1. So I already know. I got it, Natalie, thank you. -1. So that already has to go down -1. Well, if 5 minus 1 is 3, so I already know that value. So that's 3. Well, look again, it's 5. Well, I just proved again that you go down 1. So again, 3, and we're going to check our math. If I go down 1 here, 3 minus 1 is 2, so that checks out. So I'm good down till here. Well, notice now it's -2. So I have a different numerator, but I'm still going to write it here. And then I don't know this side, so x. The first thing you want to do is just try and look for a proportional relationship. Most of you will see a pattern that 1 to 2 is 5 to 10. But if that's not clear to you, that's fine. We know how to solve for a variable when given fractions. We cross multiply. So if we really just don't see the pattern, then that's totally fine. You do x times -1, which is -1x, times 5 times -2, which is -10. You divide that by -1. Excuse me, by negative, yeah. So that means I should go up 10 on this side. Well, 5 plus 10 is 15. So my missing value is 15. Yes, I'm only covering things that there will be questions. Like, sorry, the question was, will there be a lot of questions like this? No, there will be 2. Can you please do another table 2? Yes. It's not working. Can you do another? What? I'm so confused about this. Yes, let's do another. Okay. Hold on. Pause for a dramatic effect. Okay. All right, so let's do another one. The very first thing we do when we're given a table is look at a constant rate of change. We're going to go all the way down our x's, all the way down our y's, and then we're going to look at our proportional fractions, okay? -2 to -1 is up 1. -1 to 0 is up 1. 0 to 1 is up 1. 1 to 2 is up 1. Now don't get distracted. Again, don't get distracted and just immediately go, I don't know this, but all of these are 1, so up 1, that's 3. Don't do that. How did I find the 3? What 3? That's a question mark. I'm sorry, honey. That's it. That's a question mark. Suda, that's not what we're on, dear. Pay attention. Okay. -5 to I don't know is I don't know. I don't know to -1 is I don't know. Well, -1 to 1 is 2. 1 to 3 is 2. Well, 3 to 11 is 8. So take a look at what we've done so far. Okay. So the first relationship we see here is this. It's a 2 to 1. So I'm going to make my fraction 2 to 1. So I've dealt with that. Well, now right below it is, again, 2 to 1. So that shows me it's the same proportion. Again, equals 2 to 1. Well, up here I have a 1 on this side. Well, the last two just told me that if I have a 1 on this side, I have to have a 2 on this side. So I know that's a 2. So -5, or excuse me. So I know that's a 2 because there's a 1 there. Well, there's a 1 here. So again, I know that that's a 2. We've shown that. We've proven that this entire time. So this is a 2. So -5 plus 2 is what? -3. Well, -3 plus 2 is -1. That checks out. We're good. So this one is right. We're done. Now, oh hot dang, it's an 8. It's not a 2. Don't be like, okay, well, it's plus 2. I'm done over here. Notice this is an 8. That's not a 2. So we have a 2 to 1 is equal to an 8 over something. That's a question mark. Sorry. I just realized my question marks look like 3s. Sorry, I was trying to see who that is. Lana, it is a constant rate of change, or Allie? Sorry, I don't know who Shafa is. I'm so sorry. I think that's Lana. It is linear because you have to figure out the constant rate of change. This is a 2, so it's 8 over something. So something here is going to make this linear. We're trying to figure it out by the constant rate of change. So, Allie, thank you. Sorry. Das, Lana Das. I know this, guys. I'm sorry. It's very confusing with the screen names and your real names. Okay. So, either way, back to here. It's 2 over 1, so we have to figure out a number that's proportional to that. So essentially, what is half of 8? Because isn't 1 half of 2? Well, that's 4. So I'm going to plug in a 4 over here. Well, what's 2 plus 4? That's 6. So your number should have been -3 and 6. Do we have any questions about this concept still? Any questions about filling in tables, how to turn a map into a table, how to tell if a table is linear, how to tell if a table is a function? Any questions left on tables? You know, Allie, I can't because that's as many as Mr. Veeder gave me. Oh, you know what? I actually can. There's a homework sheet. Hold on. Pause. Okay, you know what? I lost it. So it's at the bottom of the homework. Thank you, Fred. Thank you, Mr. Sorry, thank you, Mr. Reader. I appreciate that. Okay, so we're going to move on from tables. Okay. So the study guide is crazy. It's almost like it's similar to the test, which, is really weird. So hopefully we all did it today. So we can go over some questions on that. Hold on, give me 1 second, guys. I lost a paper. Talk amongst yourselves. Oh, found it. Okay, we're good. All right, so in the comments, tell me, oh, who's leaving? Oh, oh, I have to go. Shadow wants to play. Okay, bye, Mr. Reader. Okay, so Natalie, what did Natalie say? I'm confused about how it can be 1, 1, 1, 4 and still be linear. Because the other side is 2, 2, 2, 2, 8. If there's 1, there's 2. So isn't that the same as half? So there's 4, there's 8. It's a constant rate of change. Yes, it's a simplifying fractions. So it has to be both proportional. Yes, correct. Okay. Bye, Mr. Reader. Okay. So let us do some. Okay. In the comments below, tell me what the synonyms for X are. The synonyms for X. Tell me in the comments below. All 3 synonyms. All right, awesome, guys. So let's go over real quick before we do f of x. Let's make sure we understand what linear equations look like. Remember, linear graphs are just a straight line. So we just covered tables. Let's look at equations real quick before we move on to their equations and their functions. Okay, so x equals. So if I graphed x equals, what x equals is that every point on that line equals the same x value. Well, isn't this one x value? So if I have a line, every value on that line has to be that x. So that's fine. It's a straight line. That's great. It's linear. But that's not a function. If I do a vertical line test, that whole hot mess is under that vertical line. There's like a million. Yeah. So x is not a function. X is not a function. Okay? Y equals, now the inverse of that is if y equals, that means every point on the line has to be here. So it would look like this. Well, again, that passes the vertical line test. So if you have like y equals x minus 3, it's the same value, minus 3. It's going to be a consistent pattern that's going to pass a vertical line test. So it is a function and it's linear. This is a linear function. It's a linear function. And it is a function because it passes the vertical line test. So x equals is not a function. Y equals is a linear function. Now, if you're given an equation that says y equals x squared, don't get tripped up because it says y equals and you're like, oh, good function, I'm done. Look what the question is asking you. If it asks if it's a function, yes, you are done because it's y equals. But if it's asking you if it's linear, if I make a table out of xy, if I say xy, well, 2 squared is 4, 3 squared is 9, 4 squared is 16. That's not a constant rate of change between those. That's a 1-to-1. This is a 5 and this is a 7. Like, that doesn't make sense. That's not linear. So this is a function. It will pass a vertical line test, but it is not linear. Here, y squared would graph like this, so it would not pass the vertical line test. So it's not a function at all. These are my pajama pants. No exponents on the y. If the y has exponents, it's not a function. If the x has exponents, it's just not linear. Okay? Screenshot this. We're moving on. Okay. All right. So we all... Okay. Sorry, guys. I swear oh, God, that's a selfie. Hold on. Ah! Oh, now you know how rough I look when I'm at home. Y'all, this hair is in a bun. Okay. Is it back? We'll wait for it to get back. No, don't log off. Sorry, guys. We still here? Comment if you're here. Oh, thank you. That's sweet. No, I don't. Thomas, your hair looks amazing in a bun. You should really rock it more. Okay. So, we all know the definition of a function. We know what a vertical line test is. We know what domain and range are. We know how to find domain and range from a set. We know what y equals, x equals, y equals x squared, and y squared equals. So let's do some tables and equations with f of x. So most likely you're going to see it look like this for the rest of your life. Tomorrow, let's be real, we might just see it like this. You might see it like this, whatever. But also, here's the trickster, because again, math hates you. Yes, x equals y is a function. Because math hates you, it could also be h of x, g of x, really anything in that general family of the alphabet, just to mess with you. So any of these is called function notation. So if you're given an equation that says like y equals 2x plus 3, and again, this is just the simplest form I can think of. If it asks you to write this in function notation, simply all you're going to do is change that y to an f of x. And what this says is that whatever x value I put into here is going to determine the outcome of here, which don't we know that x is the independent and y is the dependent? So that makes sense. Okay. So then it's going to ask you like, well, what is f of 3? Well, up here, isn't that space occupied by the variable, and don't variables represent numbers? So if we write function, no, you don't have to use the fancy f's. Allie took her comment back. I don't know what it said. Okay, so isn't this space occupied by x? And x is a variable that represents a number. So this number is now 3. So when I come into this equation and I counter an x, I'm going to replace it with a 3. So now I just have a normal equation. Well, 2 times 3 is 6 plus 3. That means that f of 3 equals 9. And what this says is that if I put 3 into this function, I will get 9 out of it. Okay? So that's function notation. Now, if you're given a table and it asks you to fill out the function... Oh, I have expo on my bed. Hold on. Pause for dramatic effect. Oh, let's solve some equations first before we do tables. Okay, so I'm just going to snag some from the homework. We're going to go... Let's do a nonlinear function. F of x equals x squared minus 4. And we're going to say f of negative 3 and f of 2. Okay, so this might have tripped some of y'all up on the homework. This is literally two separate equations. It's just asking you to plug in -3 here and solve that, and then it's asking you to plug in 2 here and solve that, and that's all it's asking you to do. So we're going to do f of 3 first. So I'm going to say f of -3 equals -3 squared minus 4. So f of -3 equals, well, -3 times -3 is 9, minus 4, f of -3 equals 5, which means that if I put -3 into this function, I'm going to get 5 out of it. Like a machine. I put it in, I get it out. So now, separately, I'm going to figure out f of 2. So I'm going to fill it out. F of 2 equals 2 squared minus 4. So again, just solve the equation. 2 times 2 is 4 minus 4. F of 2 is 0. Now, on the test, hint, hint, wink, wink, nudge, nudge, you might see, let's say we changed this and I asked you like f of -3 plus f of 2 equals. Well, all that's asking is if I plug in -3, what value am I going to get out? 5. Plus if I plug in 2, what value am I going to get out? 0. It's essentially, this is a different way of saying 5 plus 0, and the answer is 5. No, it's f of 2 equals 0. F of 2, f of 2, f of 2, f of 2 equals 0. Daniel, why are you doing f of 0? We asked for f of -3 and f of 2, and f of -3 is 5, and f of 2 is 0. 5 plus 0 is 0. Daniel, why? Okay, you good? Okay, cool. I was like, why are you doing f of 0? Wink, wink, nudge, nudge is a reference to it. By sister. Okay, I don't know what you're talking about. Potassium. Okay, that was funny. Can we do word problems? My cat is killing me. Sorry, I don't have cats. They will eat your face, guys. Okay. So, real quick before we move on. Yeah, actually I can because I found the homework. Okay. So, real quick before I move on from f of x though. I promise I'm going to come back to it. It's right there. Okay. Real quick before we move on. So, if you're given an equation, hold on. Pause for dramatic effect. Okay. So if you're given this table, like if it tells you f of x equals root x, whatever, it's going to give you the x values. So it's going to give you the x values, and simply all you do is plug in that x for what it tells you to in the equation. So x is 4, the root of 4 is 2. Root 9 is 3. Root 16 is 4. Root 49 is 7. So simply plug in the x value for that. Guys, stop. I will log off. I'm over it. Stop. $25 questions. Vaishnavi, I like how in the middle of me saying stop, you message it again. Hardy, I don't know what you mean. Will all the charts be divisible and clean room? Will there be decimals? Yeah, thank you, Casey. I have the same question. Who is that? Daniel 25 what? All right, I'm moving on. That's how you plug in an X for a table. All right, let's do a table with a missing value. Okay. No, there's no decimals. Yeah, I'm gonna do equations right after this. Okay. Missing variables or missing values. So you just go from one side to the other again. We're gonna try this again. What in the ever loving God, Allie? Okay. All right. Y'all, this is devolving. Are we gonna like keep on or should I just stop? All right, we're gonna stop. All right. I went to go get a can of water. Have y'all chilled out now? You know I have to have my LaCroix. Are we all calm? Are we good? Are we focused now? Okay. So, real quick, table with missing values before we move on. Okay. 2 to 4 is 2. 4 to 5 is 1. 5 to 6 is 1. 6 to something we don't know. Okay? All right. -4 to 0 is 4. 0 to we don't know is we don't know. That's, y'all, my question marks look like 3s. Something to 4 is we don't know. And 4 to 12 is 8. Okay. So my very first thing I look at is I have a 4 to 2. So that's going to be my rate of change I'm going to look for. So I have 4 to 2. So then in my numerator over here, I have 1, but I don't know what I have over here. Again, question mark. Well, hopefully we can look. I went up positive. I went from -4. Sorry, the question was what happened to the negative number, though. I went from a -4 to a positive, or excuse, to nothing 0. So that's up 4. Okay, so I went from 4 to 2, so I have to find some number that makes this fraction equivalent. Well, half of 2 is 1, half of 4 is 2. So I'm going to put a 2 here. Skirt. Put a 2 here. 0 plus 2 is 2. Do we understand how we got from 4 to 2 to 2 to 1? Okay, so now there's a 1 here. Well, it just showed me this is a linear pattern. I know that everything's going to be the same. Use negatives when it's going down from like 5 to 4. Yes, if the number's decreasing, use a negative. If it's increasing, use a positive. So 1 to 2, this just showed me if I put a 1 here, I have to put a 2 here. So I'm going to throw a 2 here. Well, that makes sense. 2 plus 2 is 4, so that checks out. Now, here, I don't know what I have, but I have an 8. So I'm going to say I have a 2 to 1, which is the same thing as 4 to 2. We all agreed on that. To 8 to something. Well, what's half of 2 is 1. What's half of 8 is 4. So this value is going to be 4. 6 plus 4 is 10. And I'm done. Hardy, no, honey, I'm sorry. This is the third one we've done. This is a 47-minute long video. You're welcome to go back and watch it again. It's about 20 minutes in. Don't apologize, hon. We're just not going to do it again, okay? It's at the beginning of the video. Okay, so let me check my sheet real quick. Pause for dramatic effect. Talk amongst each other. Okay, so one more time. We know what a function is. We know what a vertical line test is. We know what domain and range are. We know y squared equals x equals y equals x squared. We know how to find domain and range. We know that they go in brackets. We know we only list them once. We know what function notation is, and we know how to solve when given the x value in a function. We know how to fill in tables when given the f of x. Y'all, listen to the review and stop asking things. We know how to fill out tables when given the f of x, and we know how to find if something's linear from a table. We know how to make a map into a table to determine if it's linear or not. And we know how to tell if a map is a function or not. We know how to tell if a table is linear or not. So let's move on to word problems now, because y'all are too anxious and not listening to every single question that's on the test that I just told you. Okay. Y'all, Lana, stop with the y equals mx plus b. That's not what we're on. Excuse me. Hold on. Excuse me. Hold on. Okay. So thank you. Okay. This is my life, guys. Okay. So let's look over the, word problems. Okay. So the things that you're going to be asked from, hey guys, stop with the y equals mx plus b. I'm not going to say it again. Okay. So, the word problems, the things you're going to be asked for are equations, solutions, independent and dependent variables. Okay. So if I have a plumber that charges a fee of $50 to make a house call, so he charges $50 to pay up to your house. Then he also charges $40 per hour for labor. So I have positive 50 plus 40x. So now you can write this either way. You can say 50, you can say y equals 50 plus 40x, or you can say y equals 40x plus 50. The commutative property of addition tells us that those equal the same thing. Now, next unit, you'll learn why this is the proper way, because we're going to build on this knowledge. But for now, you need to know this. Hardy, I don't know what will there be plus minus on the tests mean. Okay. No, 40 is not independent. Batman Forever. Okay. So I'm given this equation now. Well, what this equation says is that the total amount that I have to pay this plumber is equal to $40 per hour plus a $50 fee. So I know that X equals independent, and I know that Y equals dependent. So when I just said this, I said that the total amount, so Y, Y dependent is the total amount I have to pay, equals $40 per hour, so X equals hours, plus a $50 fee. So I've now created an equation, and from that equation, I figured out what my independent and dependent variables are. So now, if I'm told additionally in this question that I hire this person for 5 hours, well, you just told me that X represents hours, so I'm going to plug in 5 for my X. So my equation is now Y equals 40 times 5 plus 50. And that independent, that 5 hours is now going to determine how much I pay. Because I was going to pay 40 and I was going to pay 50 no matter what. So this is going to be here. No, there's no decimals, guys. Decimals aren't scary. You have calculators. Okay. So all you would do is put that in your calculator and get your answer. That would be 250. Okay? So you would write Y equals $250 because this is a unit. It's at this point I asked you total money. It's a question. Okay? Let's do one more. Let me ask you this. Yes, you get to use calculators for now on. Let me ask you this in the comments while I write this down. Tell me. Hold on, I gotta think of a good way to say this. If it takes me 20 minutes to ride my bike in one direction and 15 minutes to ride my bike in the other direction, what's the independent and dependent variable? If I ask you, or excuse me, if I tell you it takes me 15 minutes to ride my bike in one path, and it takes 20 minutes to ride my bike in the other path, what's the dependent and independent variable? Don't I ride my bike both times? Aren't I going to ride my bike no matter what? So riding my bike is the independent. I'm going to ride my bike no matter what. The numbers don't matter. Like that's the addition. That's how long it's going to take me. So I'm riding my bike no matter what. That's my independent. My mode of transportation stays the same. I'm still going to do that. But what's different is the path I take. Dependent is no. Yes, dependent is the path. Dependent is the path. I'm going to ride my bike no matter what. The dependent is the path. There are two variables, X and Y. Y is the dependent, X is the independent. No, Janae, independent is riding a bike. You're going to ride a bike no matter what. The dependent is which path you take. There's nothing about how long you take, guys. I cross that out. That's the like fee. The independent is that you ride a bike both times. The dependent is which path you take. Okay? We're going to do one more word problem. Okay. Good old Mr. Thompson is trying to lose a few lbs. He is currently weighs 260 pounds. Currently. So that bad boy's got 260 on him. He's got a solid 260. That's staying there. He loses 4 pounds. If I spend money, if I lose pounds, anything that is negative, or anything with a negative connotation, I subtract per month. How much am I going to weigh? So I could either write it that way, or I also, in a perfectly acceptable way on this unit test to write it is that. Either one is acceptable. Okay? So, what this equation says is that my total pounds is going to be equal to losing 4 pounds per month off my additional 260. So what I just said is my total weight. So y equals total weight. And I just said is equal to losing 4 pounds per month. So x is how many months, number of months. So my number of months is independent. Time is going to go by no matter what. It's a cruel lesson. Time is just going to keep ticking. Y is how much weight you're going to have after. The test is going to come. It's dependent on how much you study. Neil, if you ask me for a shout out again, I'm blocking you. X and Y. So, number of months. So now, what if I'm told that his total weight is 220? Well, wasn't that the value for Y? So I'm going to plug in 220 for Y, and then I'm going to just drop down the rest of my information. Well, from there, I'm just isolating. And so you say Y equals the dependence. Allie, you said Y equals the dependent. So the total weight is the dependent variable. Correct. And X is the independent. So months is the independent. Correct. Correct, Natalie. Your score is dependent on how much you study. So now I'm just isolating for X. So this is a couple, I ship them. Let's get rid of this weirdo. It's addition. The inverse is subtraction. Well, if I have 220 and I take away 260, I now have negative 40. I canceled that out. I canceled that out. I'm going to bring over this negative 4x. Well, this person's super negative. I want to get away from him. So they're negative 4 times x. Inverse of multiplication is division. 10 equals x. So now it's not 10, it's 10 months. So remember, it should be back. Are we back? Wait, months will it be wrong? It won't be wrong, it'll get points off. You'll all do fantastic. Okay, so that's word problems, independent, dependent. We've already covered how to figure out, hold on. You already know if it's linear or nonlinear from a graph. We've done missing values on tables. We've filled out tables using f of x. You guys know how to graph. And you know from the study guide today how to do the f of a function minus the f of a function. Okay, Natalie, can I tell you I don't know my score because he told me that I can get my grade when you guys get your grade because they're going to be posted on Synergy Friday night. I don't have Synergy. So this man has told me that he's going to make me wait till Monday. And can I tell you? Not amused. Not amused. Lana, why would I say Miss Humphreys is going to say, Kalia, you're the one who knows everything? Okay, guys, last question. If you have any questions, throw them in the comments. I've already said definitions, guys. It's the same function. Vertical line test, domain range, relation, you know, the terms. The answer key to the, yeah, I can take a picture. Okay. I'll take a picture of the answer key and post it online. Okay, last question. So from the study guide, we had g of x equals negative 2x plus 4. And we had h of x equals x squared minus 3. Okay, so these were the two equations that were given to us. And what it asked us for was g of 3. Nope, sorry. All of that's wrong. Okay, it asked us for h of 3 plus g of 3. So all that's saying is if I plug in 3 for this h and for this g, the output, I'm just going to add them together. So let's do it. It says g is 3, so I'm going to plug in g of 3 equals negative 2 times 3 plus 4. G of 3 equals negative 6 plus 4. G of 3 equals negative 2. So now I'm just going to write a little negative 2 up there so I know what's going on. Okay, Casey, you say you're going to get a 60 again. I'm going to figure out who you are from these comments, and I'm going to make you do burpees. H of x equals x squared minus 3. H is 3. H of 3 equals 3 squared minus 3. And then h of 3 equals 9 minus 3. H of 3 equals 6. So now what this equation is asking me is 6 plus negative 2. That equals 4. So my answer to h of 3 plus g of 3 is 4. Allie, it's up so you can screenshot it. I've been holding here for a while. Oh, Natalie, you're so sweet. All right. See you. I will not be at the study session tomorrow. I'm going to a job fair, so send me positive vibes, guys. Let me just last double check, make sure everything is covered. One last run through, and I lost the paper again. You guys, kill the game. There we go. Okay. All right, one last run through. Definitions. Functions, vertical line test. Know what domain and range are. Know your function equations like y squared, x squared. Know how to find domain and range, and don't repeat your values. Make sure you give your brackets. You know how to find f of x equations or function notations. You know how to fill out tables when given a function, and you know how to tell if tables are linear. You know how to read maps and tell if they're functions, and you know how to turn a map into a table to see if it's linear or not. You know how to tell if tables are linear. You know that x is independent and y is dependent, so write out your equation and figure out which is representing which. You know how to create equations from word problems and then plugging in the value for x to solve or y. You know how to perform the vertical line test. You know how to fill in values for tables. You know how to fill in tables for equations. You know how to graph things. And you know how to do like functions plus functions. So you kids rock this study session tomorrow. I cannot wait for all of Mr. Peter's texts about how fantastic you all do. I'm like dying for these test scores. I cannot wait, guys. You are awesome. I'm proud of all of you. And I will see you on Monday, okay, guys?